in this section, we're going to be talking about formal charge. Formal charge is the hypothetical charge you obtain by assuming the bond electrons are equally shared, which means that each atom gets one of the two electrons in a bond, and that the electrons of each lone pair only can belong to that one atom. So again, these are the lone pairs. So these lone pairs only belong to oxygen. And this is a double bond here. And so in each bond, oxygen will get one and carbon will get one. And we're going to assign those based on that. So each atom in a bonded pair gets one. And when I have a lone pair, both electrons go to that atom. Now, this formula is not given to you, but this is the way that I will shorthand this, just so you know. So Fc, for formal charge, is equal to the valence electrons, Ve, minus 1/2 of the bonded electrons, minus the lone electrons. So lone electrons. And so we're not talking about pairs, we're talking about the individual electrons. And then the sum of the formal charge should be equal to that of a molecule, which a molecule is a molecule because it has no charge, so it should be 0, or for an ion. So for example, SO4 2 minus, the formal charge sum should equal to a -2. So in this example here from the internet, you see the fact that I have, this is the structure H2CO. Okay, and so hydrogen, these two hydrogens are equivalent, so it's not going to do this hydrogen. And equivalent means that there's the same number of lone pairs and the same number of bonds. So this hydrogen here, of course, hydrogen has one valence electron, and then it has one in a bond. So this is actually showing a slightly different way of doing this, and it doesn't matter which way you want to do this, but you need to stick to one way to do it. It's valence electrons number minus the number of bonds minus the lone electrons. I don't prefer this way only because of the fact that you have to differentiate between bonds and electrons here, whereas this way it's only dealing with electrons. But anyway, so this is one valence electron minus the one in the bond, and there are no lone electrons. For the oxygen here, this is the valence electrons, this is number of bonds, and these are the lone electrons. Actually, let me do this again. So this is valence electrons. This is the number of bonds. 1, 2. I can write it bigger this way. And the 4 goes to the lone electrons. Okay, so that's how you do this. And then when all of these are 0, so this is a molecule, when I add these up, 0, 0, and 0, I get a sum of 0. Now, we use the formal charge to write the Lewis dot structures and to choose which structure is the best. So we want to choose the structure having the lowest magnitude. So I have two examples here. This is carbon dioxide. This is the structure with double bonds for both carbon and oxygen. You see it's 0, 0, 0. If I do it with the carbon on the outside and oxygen on the inside, but same structure, double bonds, I have a +2, -2. So this one's not as good because of the fact that it's a +2 and a -2. This one's carbon in the center again, but has a triple bond versus a single bond. And again, is not good because I have a -1 and a +1. This one, I have carbon on the outside again, and this one's not good because this one's even the worst of them all because it's a -3, +2, and +1. And lastly but least, this one has carbon on the outside but has a triple bond here, and I have a -1, +2, -1. So that's why that one's bad. So I want to have the structure with the least number there. And so if I have two that have the same set of formal So let's say I had two that have -1 and +1. Then I would want the carbon, which is the least electronegative, to be the +1, and oxygen, which is the most electronegative, to be the -1. Okay, and here is another example of when I have dinitrogen monoxide or nitrous oxide. This one, the formal charge of this is this end, this is this end, and I know because of the 6 minus 8. This is the formula I gave you. It's 1/2 of the number of bonding electrons. And so this one has 0 plus 1 minus 1, and this one has a -1 plus 1, 0. Now, between these two structures, which one is more preferred? So I want the most electronegative to have the formal charge. So between nitrogen and oxygen, which one's most electronegative? It's oxygen. So this right here is the preferred structure because they both have +1 and -1. But here, oxygen being more electronegative is the one that has the negative charge to it. Okay. So earlier we did bromine cyanide, bromine carbon nitrogen. And so to do this one again, okay, we have Br, of which there's 1 times 7 to give me 7. Carbon, there's 1, and it has 4 valence electrons. And these are again coming from, this is bromine here, and 7. Carbon here, and 14. And nitrogen here, and 15. So that's 4. Nitrogen is 1 times 5 to equal 5, so that's 16 total. This one's a little bit different. Carbon's on the inside, so I have carbon with a nitrogen and a bromine on either side. It doesn't matter which side you draw is which. So by doing that, I used up 4 electrons, leaving me 12, and then I go 2, 4, 6, 8, 10, 12. But I'm out of, and carbon needs to see more because of the fact that it's single there. So I can either, now let's go to my colors, okay? I can either take 2 electrons in here, and so I have bromine, single bond, triple bond carbon, single bond nitrogen as one structure. I can have where bromine shares 1 and nitrogen shares 1. So that's going to be Br with 2 double bond carbon, double bond nitrogen with 2 lone electrons. Or the last one's going to be the fact that nitrogen shares 2 and carbon and bromine only has 1. So it's going to be bromine with a single bond, triple, or 3 lone pairs, carbon, nitrogen with a single. Okay? So which one of these 3 structures is the most correct? So the formal charge of bromine is going to be 7. Again, this number is the same as that number. Minus 1/2 of, I've got 2, 4, 6 electrons. And I've got 1 lone set of electrons, so that's 2. So 7 minus 3 is 4, minus 2 gives me 2. That's a plus 2. I have the formal charge of carbon, which is going to be 4 minus 1/2 of 8. It's because there's 2, 4, 6, 8. And carbon has 0 lone, so that's going to be 0. And the formal charge of nitrogen is 5 minus 1/2, and this structure only has 2. And then minus, it has 2, 4, 6 lone electrons. So 2 minus 1 is 4, minus 2 gives me minus 2. Okay. For my next structure, I have formal charge of bromine, still being 7, minus 1/2, this time it's 4, minus 4. So this is, oops, I didn't need this. So that's 7 minus 2 is 5. This gives me a plus 1. The formal charge on carbon is 4 minus 1/2 of 8 minus 0 to give me 0. And the formal charge of nitrogen is 5 minus 1/2 of 4 minus 4. So 2 in the bond, which is 4 electrons, 2, 4, and 2 lone, 2, 4. Okay, so 5 minus 2 is 3, and so this is a minus 1. Okay, and now I'm going to stop doing carbon because carbon you see is 0 and 0. In all three of these structures, carbon has 4 bonds and 0 lone pairs. So the formal charge on carbon is going to stay 0. Oops, of carbon is going to equal 0. The formal charge, my pen's really acting up, formal charge of bromine is 7 minus 1/2. In this structure, there's only 2 minus 2, 4, 6. So that's going to be 0. And the formal charge of nitrogen is 5 minus 1/2 of 6. And again, the 6 is 2, 4, 6 minus the 2 for the lone there. So 5 minus 3 is 2, minus 2 is 0. So because of that, this structure right here is my preferred structure. Okay, and in the next video we will do some more problems.